When you look at the steps that I gave you, the first thing it asks you to do is apply the distributive property. So I'm going to look for where I see parentheses with a factor on the outside that is being multiplied by the parentheses. So I see a section over here, and then I see a section here in the front. And I'm going to go ahead and multiply this factor of 4 through, and I multiply 4 times the 3x squared, and then we are subtracting the 4 times 2. Then I add to that the negative 3x, and you'll notice that in these problems, I wanted to write it like they do on the EOG, where they put the negative symbol up at the top. So when you see this, it just means that this is a negative number. Often on the EOG, that's how it's written. Then we're adding to that 2 times 6x minus 2 multiplied by 5. And then finally, right after this set of parentheses, we have an addition sign, and we're adding a negative x squared. Then I'm going to go ahead and figure out the products. So 4 times 3x squared is 12x squared, minus 4 times 2 is 8, plus the negative 3x, plus the product of 2 times 6x is 12x, minus, and the product of 2 times 5 is 10, plus the negative x squared. The next step that I asked you to do, step 2, is to change any subtraction to addition. So I see subtraction right here, so I'm going to keep this number, the 12x squared. I'm going to change the subtraction to addition, and then I'm going to record the opposite of 8, which is negative 8. And then I copy the rest of this problem until I get to another part of this problem that is subtraction, and I keep the 12x, and then I change the subtraction to addition, and then I change the positive 10 to a negative 10, and now all that we have between is addition. Every single symbol in between is addition. And according to the commutative property of addition, we can change the order. And I'm going to go to my circle tool actually now, and I'm going to grab a different color, and I'm going to go ahead and start pairing my like terms. So I see that I have a 12x squared, and then I have a negative x squared. I'm going to change to a rectangle now, and I'll change colors as well. And I see that I have a constant term, a negative 8, and another constant term, a negative 10. And then finally, I have a negative 3x that goes with the positive 12x. From here, I'm going to order. So I'm going to start by writing the 12x squared. Oops, need to go to scribble. 12x squared plus the negative x squared. So there's still addition in between these terms, and then I'm going to cross out what I've written. Then I'm going to add next the negative 3x plus the 12x. So I'm finished with those. And then I'm going to add the constant terms, the negative 8 plus the negative 10. And then I'll look over the problem and I see that I have taken care of every single term. And now I can start combining. So let's think about 12x squared and negative x squared. Well, negative x squared is the same as negative 1x squared, and I'm focusing on the coefficients. So I'm thinking about adding 12 plus a negative 1. Well, 12 plus a negative 1 is equal to 11. So I have 11x squared. Then I'm going to add to that negative 3x plus 12, and I focus on the coefficients. Negative 3 plus 12. Well, if I would write this out using integer chips, then I would actually have 3 positives cancel out with these 3 negatives, and then I'd have an additional 9 positive chips. So negative 3 plus 12 is equal to a positive 9. So I'll record 9x, and then I'll have 8 red integer chips and 10 red integer chips, which gives me a total of 18 red integer chips. Now from here I need to look over the problem and see if there are any like terms that I can combine. Since this x has a power of 2, and this x actually has a power of 1, when you don't see the exponent it's a 1, they are not like terms, because remember, for them to be like terms they have to have the same variable, the same exponent. So this is actually my final answer, 11x squared plus 9x plus a negative 18. That is my final answer.